So let's do this. What was the first question on there?
Find the values of the 6 trigonometric functions as fractions for angle 0.
Right. So trigonometric functions are as follows. You've heard of SOHCAHTOA before, right?
I think I've heard of it.
So SOHCAHTOA stands for sine. It's written this way. SOHCAHTOA. We use this as a mnemonic to help us remember. Sine equals opposite over hypotenuse.
Okay.
So sine has an inverse. Like the inverse of sine is called cosecant. So it's written this way, cosecant. And it just means flip. So we're going to flip the sine is going to be hypotenuse over opposite. But there's yet one more way we could write cosecant. We could write cosecant as 1 over. It's going to actually give you these formulas. Am I right?
Yeah, she said she's going to give us formulas.
Okay. So then we go on to the next one, cosine, right? So then I'll just go faster. Cosine is defined as adjacent over hypotenuse. The inverse of cosine is called secant, which is hypotenuse over adjacent. You just flip it. But there's one more way to write it. We could write it as 1 over cosine. So these are all going to be given. Then you have tangent, opposite over adjacent. Cotangent is the inverse of it. So that's why it's flipped. There's one way to write it, 1 over tangent. Tangent is special because we can actually have 2 other ways to write tangent. Sine over cosine. All right. So with that knowledge, we go back to the first question, which you have a triangle given to you. I'm going to erase this stuff and that stuff. Ignore this for now. We'll come back to that later. So the first question on the review is you have a triangle. Give me the dimensions. What's given?
6 on the 6 on that side,
Mhm.
and then on the bottom 8, and then there's a 0 like in the corner of
Right.
the top corner.
That's
Yeah.
theta.
Okay.
It's the Greek letter for like an angle, an unknown angle. Yeah. So we're being asked to find all the 6 trigonometric functions.
Where says find the 6.
Yeah. So the 6 are these: sine, cosine, tangent, cosecant, secant, and cotangent. So we got to find all these.
Okay.
So before we start doing this, we need the missing side here. How do you find the missing side of a right triangle if you're given 2 of the sides? Give you a hint. It's as easy as ABC. That's the hint.
Just add those 2 sides together and then
Pythagorean theorem. A squared plus
b squared
equals
equals c squared.
C is the hypotenuse. I don't care how you orient these 2, but C must be the longest side, which is the hypotenuse. Across with a 90-degree angle, that's got to be here. So can we use that to find the hypotenuse real quick?
So you do a squared plus 6 squared. Is that what it's saying? Basically?
Well, A is 6, B is
8.
we're looking for C. So did you plug those in here?
So you'd like it's just 8 plus 6, and then you get the
Squared. The formula says
Yeah,
squared.
so 8 squared
Yeah.
plus 6 squared equals 100.
So we have 100 equals C squared, right? What is C?
50.
How'd you get that?
Just divide the no.
No. To undo squared, you square root.
Oh yeah, so square root 100 or
Square root of both sides really, but yes.
Yeah.
So C is?
So it's 10.
So the missing side is 10.
Yeah.
So we needed that to be able to do this. So let's set it up. We'll say sine theta. So sine is what over what?
O over h.
Opposite over?
Opposite over hypotenuse.
So when you're looking at theta, what is opposite from it? Which side is opposite from it?
Opposite from the 10.
From theta.
Oh, 8.
8. What is the hypotenuse of this triangle?
I don't really know.
hypotenuse of the triangle? Hypotenuse is the longest side of a triangle.
Oh, okay, so 10.
So when you simplify this, it's 4 over,
It's 4/5.
which means if we know the sign, you automatically know its inverse. So you automatically know cosecant theta is going to be what?
Hypotenuse over.
Yeah, but you already have the answer, so just flip it. 5
so
over.
5/4.
Yes. So we go to the next one, which is cosine theta. Okay, cosine is adjacent over hypotenuse.
Mhm.
Looking at theta once again, it's always based on the angle. So what is adjacent to theta?
Wait, sorry, I just had to write that down. Can you say that again?
Sure. Cosine is defined as,
Adjacent over hypotenuse.
so here's theta.
Mhm.
What is adjacent to it?
6.
So 6 over hypotenuse, which is,
10.
does that simplify?
Yep. Simplifies to 3/5.
What's the inverse of cosine?
Inverse of cosine is
Secant.
secant.
So what's our answer going to be for the secant?
It's gonna be 5/3.
Very good. All right, now we'll do tangent. What's tangent?
Tangent is opposite over adjacent.
So opposite,
8,
adjacent,
6.
simplify.
To it'd be 4/3.
Okay, what's cotangent? The inverse of it.
Adjacent over opposite, so it would just be 3/4.
Done. You found all 6 answers.
Alright.
Pretty straightforward, you think, or difficult?
Yeah, that's very straightforward.
Yeah, it's not too bad. Mic check 1 2 1 2. Yep, I think the microphone is working. All right. Oh, I don't know if that's visible on the screen. It is visible. There's a glare on it. I'm not sure how to get rid of it. I'll let it do. I'll let it stay. I gotta figure out the glare situation. All right. So that means you might be able to work out the next few problems. In fact, we might be able to skip a bunch of them because it's the same thing. Wash, rinse, and repeat.
Yep. So, and then it's just the same thing for these.
Well, did you read the directions?
Use a trigonometric function. Trigonometric function to find the value of x. So
not so much the same because the directions are different.
Yeah.
All right. So then we have
number
Okay.
2.
number 2. Let's sketch it. So we have,
So it's like the same. It's like the same triangle.
Cool.
And then 30 degrees, bottom left.
thank you.
X on the hypotenuse.
All right.
Like the bottom part.
This one?
Yeah.
Okay.
And then 8 on the right.
This one?
That's it.
Got it. And we're being asked to find x, right?
Mhm.
So what's this missing angle here?
That'd be 30 degrees too.
30, 60, 90.
Oh, okay.
It's one of the, so there's 2 special triangles that you will hear about. This might be when you were out sick,
Mhm.
but one of the special right triangles, it's a famous one that we definitely want to know how it works. It's called a 30, 60, 90, right? In fact, let me draw this off to the side here for you real quick. You need to know this. 30, 60, 90 is a special right triangle whereby you'll have 30 degrees in there and 60 degrees.
Mhm.
So someone who lived many years before you and I came into existence made our life easier by giving us these rules. What rules, you ask? Here they go. The short leg, which is always next to the 60,
Mhm.
he called it x.
Yep.
And the hypotenuse is always double whatever that short leg is. So it would have to be 2 times x,
2 times 60.
2x. I'm just saying if we know this is x.
Oh, so that'll just be 2x.
Yes. And then the long leg, the guy is always adjacent to the 30-degree angle. He said that you take the short leg and you multiply to √3. These are facts. We can't change this.
Okay.
So when you compare this to what we're given, what we're seeing is they give us this short leg as 8. Well, what does that make the hypotenuse?
That makes that 16.
Good.
right there.
And that makes this guy
Um,
8 root or 8 root 3.
Alright.
That's why those special right triangles come in really clutch. Uh-huh. Oops. All right. Okay. You good?
So the answer would be 8 square root 3.
Correct. Now, that only works when you have the special right triangle, the 30, 60, 90. We can explore this later when you don't have a quiz. We definitely want to know this better before the test.
Yeah.
So the next one that you're given
Is triangle.
same triangle.
Yes, yeah, same triangle except it's like opposite, like flipped. And
So-
then
Okay.
hypotenuse is x.
Okay.
And then the straight side is 5.
They're both straight.
The 5 is on the left of it.
Short leg or long leg? There's a short leg and a long leg.
Short leg.
There's a 5.
Yep.
Got it. So that's all we're given.
And then 60 degrees.
Same place. Yeah, good. So guess what? We need to find the hypotenuse. We're given the short leg. So based on those rules again, if you know the short leg is 5, well, what's the hypotenuse going to have to be?
10.
10. Because the person who, so you see why this person really helped us out.
Yeah.
They saved us a lot of time. So you got to know this. There is another special right triangle. I'm going to mention a triangle that you need to know. I'm going to mention it. It's called a 45. I don't know if that's visible. Can you guys see this? Yeah, you can. Okay. Yeah. It's a 45, 45, 90. And it's got its own rules. Oops. It's an isosceles triangle. It's got its own rules. It will be useful for you to know it as well. So we have 45 degrees, 45 degrees. The legs are equal. So that's, they just call both of them x's. And the hypotenuse is going to be x square root of 2. Knowing those two really saves you a ton of time. Yeah, dude. Get this out of the way. All right, cool. Could you do me a favor and looks like the battery is low on this thing. Could you turn it? See the handle on the left? Turn it that way ever so slightly. Very, very slightly to that direction. No, the other direction.
This way.
Yes, ever so slightly. Oh, actually, go back the other way. I'm sorry. Go back the other way. Keep going. Keep going. Keep going. Keep going. That's good. I'll go back this way a little bit. That's good. Perfect. Right there. Yes, I appreciate that. Looks like the microphone is dying on me though. The battery is really low. All right. So yeah, go to the next question.
All right, so
can try it.
We already got the answer for this. Is it 10?
Yeah.
That's easy. And then the next one, it's the short leg is x.
Okay.
And they give us 10 on like the top.
Long leg, short
Long
leg. There's
leg.
no top. Long leg
Long leg.
is 10. So short leg, long leg, hypotenuse. Those are the 3 terms you got to use. So we're looking for this one, right? So this one's a little trickier because it's not as direct as the other ones. Now, by rule, the guy said the long leg is always what?
X square root 3.
Yeah, this time they gave it to us as
10.
So you set a little equation. You say, x root 3 equals 10. Does that make sense to you?
Yep.
And then we'll use our algebra skills to get x by itself here.
And then I'm just making sure this is the same as that, right?
Correct.
All right, cool.
Just turned one way
Yeah.
or another. Yep. So do you understand what we're doing is just taking the guy's rule and we're equating to what the question is saying. So we need to get x by itself here. Using your algebra skills. How do we get x by itself?
You like take away the square root by Would you like literally do 10 square root 3 and put in your calculator?
No, use your algebra skills to get x by itself.
Oh, just divide both sides by, or square root 3 to another side? Like undo it?
Well, how do you get x by itself? That's the question. I don't think we just want to get x by itself. That means get rid of the root 3. How are you going to get rid of the root 3?
Do it to the other side, or just divide?
Divide.
Yeah, divide by square root 3.
Right? That's the only way these go away, right? So we end up having x equals 10 over root 3, but we have a little bit of a problem here. We can't have a radical on the denominator. How are we fixing this? Times it by. If you want to get times it by the radical that you want to get rid of, that's called rationalizing the denominator. That's a fancy name for it. So ultimately, we end up having, this becomes x equals 10 root 3 over, what's any root times itself?
Just 3.
It's just whatever the number is, yeah. So we then know your short leg is 10 root 3 over 3. That's what you were looking for, I believe.
Yep.
Yeah. So as you can see, some of them are pretty straightforward. Some others require a little bit of algebra. Okay. So let's keep going.
Find the value of x, round to the nearest degree if necessary. Show your work.
Well, yeah, but what kind of triangles are they?
One's the bottom's 4, and then the hypotenuse is 5, and then x degrees.
Okay. Gotcha. So we're looking for the missing angle. So they're right triangles still. So I'm going to sketch what you have. It looks like we have a triangle that looks like that. 90 degrees.
And then 4 on the bottom.
4 here.
Yep. And then 5 hypotenuse.
Got it.
And then x degrees.
Degrees. Got it. So we're looking for the degree measure. Okay, cool. Man, my drawings are kind of bad, but there we go. So here's the thing. We're going to use one of these SOHCAHTOA. You have to ask yourself, based on what I'm given, which of those makes sense? Would I go with sine? Would I go with cosine? Or would I go with tangent? So here's the angle. What is this relative to that angle? Is it opposite, or is it adjacent, or is it the hypotenuse?
It's adjacent.
Correct. So we have adjacent. What's the 5?
The 5 is the hypotenuse.
So now we have adjacent and hypotenuse. So that means we have to go with which one?
Sine. Right. This one.
Cosine.
Cosine.
Adjacent. Yeah. So cosine of the angle, which is cosine x, equals adjacent over hypotenuse. Now here's the secret sauce. You have your calculator on you, the TI-84 or whichever one you have.
Yeah, I have it.
So listen carefully. Anytime you're looking for an angle measure, and we are looking for an angle, on your calculator, you have to go to the one that says -1. Do you see cosine to the -1?
Sine -1.
This is cosine.
Oh yeah, cosine -1. I see it.
How do you get to it?
You just press second and then.
Exactly. And then you enter 4 over 5 in there, 4 divided by 5.
And then put parentheses around it.
Yes.
And then will that be your answer?
Well, yes.
Okay.
What does it say?
It says 0.64.
Ooh, so that means you're in the wrong mode. If you click on mode, you'll find that you're in degrees. We don't want to be in degrees.
Okay.
We want to be in.
What should I like? How should I change it? Like the mode? Because I see.
Yeah, you see how it says it's probably highlighting degrees right now. Am I right?
Yeah. So if I click on mode, it goes radian, degree. How do I like?
Move it over to degree, radian, enter, and then get out of it. It automatically does that for you.
There you go.
Does that make sense?
Mhm.
Cool. Cool beans. Trying to figure this thing out, man.
Yeah.
Trying to figure this thing out. It's not letting me.
And then you, okay, right here, so cosine, what is that? 36 is what I got.
Read the directions because it might have told you to round the nearest anything. It's not just 36. Is
Yeah,
it? Is it just 36?
36.869.
Yeah. What does it tell you to round to or something? Or
Round to the nearest degree if necessary, so.
So what do you think?
37.
37 degrees.
Uh-huh.
So let's, yeah, I'm going to repeat. Anytime you're looking for an angle measure, you have, that's when you use the -1.
Okay.
Whatever, this time it was cosine. It could have been sine, it could have been tangent, but yeah, whichever trig identity you're working with is what you plug in. So let's look at the next question there. What does it say?
Short leg 7, hypotenuse is 13, and then x degrees.
Short leg 7, hypotenuse 13. And cool. So back to the drawing board again. Relative to the x, what's the 7?
Like on the opposite side.
Yeah. What's 13?
Hypotenuse.
So which of those three makes sense?
Just would it be like out of the sign, the CSC?
No. So we don't use the CSC. We only use this top line here. These are the fancy versions.
Okay, so then that one, the sign.
Yeah.
Sign.
So sine x equals what over what?
Equals 7/13.
Correct. And then
you put that in your calculator.
yes, since you're looking for an angle measure. Let me see if I have a battery. I gotta switch out the battery for the microphone real quick.
Maybe 33 degrees.
Do you think about this stuff? Difficult, easy, kind of?
I mean, it's a little more difficult than some of the things, but it's not not too hard. It's like, reasonable.
How do you change that? After that fixes it. Okay. All right. Are you playing catch up or this is actually tomorrow's quiz?
This is my school.
Yeah, none of the guys gave me this, which is kind of very weird.
Well, there's 2 parts to it. I have to make up I have to do both parts, so I just have to do this whole the whole thing.
So this is makeup then.
Not all of it, because she gave us a part 1 to it and then a part 2, but it's all put into one review.
Okay. All right, let's keep going then. What's the next question on there? Or type of question? If you get this, we can move on.
Yeah, I mean, I get this. So
yep.
Find the exact value of each trigonometric expression.
Yep.
So sine 150 degrees.
Oh, so I wonder if you're allowed to use your calculator for this, because you can.
Yeah, I think we are.
Yep.
Because she didn't say no calculator or anything like that when I asked her today.
Okay. So the problem that you're going to see when you enter it there. So go ahead and do sine 150. It'll give you a decimal, which is not the exact. A decimal is like an approximation. It's been rounded.
Put the 150 in parentheses.
Did it open a parenthesis for you? I mean, if it opens a parenthesis, what do you think needs to be done? Some of these things yeah.
I did sine 150 and then I just said error.
Let me see.
Yeah.
No, you did sine of the -1. We're not.
Oh.
We're doing only the plain old sine.
Okay. Um, How do you like do just the plain old sign?
Say sign on the keyboard there. You just don't hit second. The same key that
Oh, okay,
yeah.
yeah. Okay, I see now.
What-
And then 150.
Mhm.
0.5.
yeah, but see, they wanted the exact answer, so I would write that as 1/2, not the decimal
Mhm.
version, 1/2, right?
Yep.
So you may not be allowed to use a calculator. That's something you want to ask your teacher.
Okay.
So I'll show you if you didn't have a calculator, that's why we need this unit circle, this thing right here.
Yep.
But what's the next angle? Maybe I can tell if you're allowed one or not.
Cosine 270.
Yeah, okay. So you can do that on the calculator, actually. It's not going to be like a weird number.
0.
Maybe you are allowed a calculator. Next one.
Cotangent 135
Yeah, you can do cotangent on there.
on the calculator.
Yeah.
Okay.
There's
so
no
then
button for it.
I think we might need to use that circle.
So you have seen this before in class?
Yes, I've seen it in class. So we
Got it.
probably do actually have to use that. I don't think, I mean, I wouldn't see her saying no calculator, but I mean, I can still learn it that way.
Sure. So real quick, focus only on this first, just this quarter here. By the way,
Yep.
it broken into 4 quadrants. What do you call this quadrant?
Is there like a certain name for it?
Yeah, there's 4 quadrants. So quadrant 1, 2, 3, and 4. Which is it? This
That's quadrant 4,
3.
3.
It starts here. Quadrant 1,
1, 2,
2,
3,
3, 4.
Okay.
So focus only on the first quadrant. These are the critical angles that you have to be familiar with. It starts off with 0 degrees, obviously, right here. This is 0 degrees. And the point here is 1, 0.
Yep.
Then it goes to 30, 45, 60, and then 90 degrees. So notice while you're in here, there's like points. This is called the unit circle because the radius of it is 1. Uno, 1. Uno means what? 1. So if you measure the distance from the center to that point, it's 1. The distance from here to here again is
1.
because radius, all these are 1s.
Yeah.
That's why it's called a unit circle. Now, realize that at each angle, we have an ordered pair. 1, 0, root 3 over 2, 1/2, root 2 over 2, root 2 over 2, 1/2, root 3 over 2, and so on and so forth. You get the point?
Yep.
What is important here is the x value and the y value, we call them sine and cosine and sine. So the x value is called
Cosine.
the y value is called.
Sine.
So if I asked you for the cosine of 60 degrees, you go to 60 degrees and look at,
It would be 1/2.
and so let's check it on the calculator. Could you do cosine of 60 and see if it's 1/2 on your calculator?
Cosine of 60.
Yep. It better be, otherwise we are liars.
Yeah, 1/2.
Very good. So when you were being asked for the cosine of 150, this kept going, right? So we have 90. This next angle here is 120, 135, 150, and then 180 degrees. So if you remember, you were being asked for the sine of 150, wasn't it?
Sine of 150.
The previous question, was it sine of 150?
Yeah, number 8 was sine of 150, so that would be 1/2.
That's how you got the 0.5. So the current question is asking for the tangent of what?
135.
So tangent of 135. The problem is we don't have tangent in here. However, look, we define tangent as what?
Sine over cosine.
So basically the y value divided by the,
X value.
so you go to 135, take the y value divided by the x value. So tangent of 135 is going to be root 2 over 2 divided by negative root 2 over 2, which is basically -1. Any number divided by itself is 1.
Wait, so tangent is the same as cotangent because it's COT, it's not.
Oh, it says cotangent? on
Yeah,
your-
COT.
Oh,
cotangent.
well,
My bad.
it'll be the same answer.
Alright.
But I forgot that cotangent is now flipped. See, cotangent is over here. Cosine over.
Oh, cosine over sine.
So x value divided by the.
Oh, my bad.
So we have negative root 2 over 2 divided by root 2 over 2, which again, anything divided by itself is 1. And a positive divided by a negative is a negative. So -1. Does that make sense to you?
Mhm.
All right, cool. So guys, I know we probably had a chance to meet with a couple guys and none of them told me that you guys had a quiz. This is for you. So you thank Patrick for helping you guys out. Next one,
What's CSC called?
cosecant.
Cosecant.
Yep.
Okay, so cosecant 30 degrees.
Cosecant 30. All right. So we're doing cosecant 30 degrees. Again, the unit circle doesn't have cosecant.
Mhm.
Thankfully, we have a definition for cosecant.
Yeah.
What is it?
Hypotenuse over opposite.
True, but we don't have a triangle here. What we're dealing with is this. So we want to go with the one that's actually beneficial. Cosecant 30. We don't have a triangle to go with this. We have to go with
Oh, yeah, I didn't see that one. So 1 over sine.
yeah. So so we go to cosecant 30 degrees. Here's 30 degrees.
And then so it'd be 1/2. So 1 over a half.
1 over 1/2, exactly. And if you remember the little shortcut, I might have showed you this a while ago, where if it's okay with you, I'm going to write this 1 on the numerator as 1 over 1, just to make it look balanced. And we can do the outer multiplied over inner multiplied. So 1 times 2.
1 times 2 is 2. And then 1 times 1.
Yeah. So the cosecant of 30 is 2. Make sense to you?
Yep.
Very good. Shall we continue?
Yeah. So now it's a word problem for them.
Sure thing. Go.
The angle of elevation to the top of a tree from a point on the ground 60 feet from its base is 35 degrees. How tall is the tree to the nearest foot?
Angle of elevation was what?
Elevation.
35 degrees?
Yeah, 35 degrees.
60 feet from the base?
Mhm.
And we want to find the height of the tree?
Yep.
Cool. So when you read these word problems, you definitely want to sketch them, right? So I have a question for you. I'm going to pick your brain here for a minute. Angle of elevation. Is it you looking downward or you looking upward?
Upward.
Yeah, because elevation, right?
Yeah.
So if you're going to sketch this, there's a tree. I think you mentioned a tree.
Mhm.
This is the tree. Doesn't have to be a fancy drawing. I'm just going to draw, a nice tree.
Yeah.
And then this is the ground where the tree is planted. And then I'm just going to complete this by drawing it right. It's really about drawing a right triangle. That's the point.
Mhm.
We know that the angle of elevation is 35 degrees.
Mhm.
So where's the person standing? Where's the 35-degree angle, in other words?
Like on a point, like right where it like meets together. Or
Where? There's 2 places. I'm looking at here and I'm looking at there.
right, yeah, right there.
Bottom right or what?
Oh yeah, bottom right.
So this would be 35 degrees. That is correct. Because the person will be looking up to the top of the tree.
Mhm.
And we know the distance. Wait, I'm sorry. The angle was 35. Yes. And the distance from the base is how far away is this person from that base?
60 feet.
Yeah. So this is 60. And what we're looking for is the height of the tree. So this is what we need, H right here. How tall is this tree, right?
Mhm.
Yeah. So this goes back to like what we were just doing a minute ago. How would you find this side given this information? Which of these 3 would make sense? Sogatella, which of those 3?
Wait, which of what, dude?
Sogatella.
So the base is 60. And then would it be wait, so which ones are we looking at again out of like all those?
SOHCAHTOA.
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 Oh, okay, yeah.
So again, you never use these extra
Yeah,
ones.
okay, I was looking at those. My bad. Use the not that right, obviously, so tangent.
It depends on what you're given. Yeah, you're right. It's tangent. So you have, this is opposite, right?
Mhm.
And this is adjacent.
Yeah.
So, oh, TOA, opposite,
tangent.
adjacent. Very good. So we're going to go with tan 35, right? Because it's always tangent of whatever angle.
Yeah.
Tangent 35 equals what?
Equals 60
Wait,
or H.
yeah, because opposite over.
Yeah. So H over 60.
Yeah, opposite over adjacent. Now our goal is to solve for H using algebra. How do we get H by itself?
You have to multiply.
It's an incomplete sentence.
Hmm.
That's an incomplete sentence. Multiply by what?
Multiply by, if you want to get H by itself, multiply by 60.
That's it. That's better. Multiply by 60. Both sides. Very good. Guess what? 60s are gone.
Mhm.
So the rest, you'll let the calculator do for you.
Yep.
You literally enter this 60, 10, 35, and it'll do it for you. Oops.
42 feet.
Okay.
Is what I got.
Did you say round to the nearest anything? Always follow the direction.
Yeah, but it's 42.01.
Ooh. So they say round to the nearest.
They
Foot?
say round nearest foot.
Okay, yeah, then you're absolutely right. 54 what? Feet.
Oh no, I said 42 feet, not 54.
Oh, you're right. You're right. You're right. You're right. You're right. You're right. 60, 10, 35. Yeah, 42 feet. Very good. 42 feet. All righty. That's that.
There's another word problem.
Cool.
A 30-foot support cable is attached 22 feet up from the base of an electric pole. What is the measure of the angle to the nearest tenth that the cable makes with the ground?
Electric pole,
Mhm.
cable. Okay, this is the cable. Whoa, my drawings, man. I'm struggling. All right. So the point is, we need a right triangle. This is the pole, whatever. Here's a right angle. Now, how long? What else is given? I've kind of lost track of what you said.
So it's 22 feet up from the base of an electric pole. So the 30-foot support cable is attached.
Pause. So the support cable is 30 feet.
Mhm.
Where's that going, in your opinion?
The short leg.
This is the pole.
Oh, okay.
This is the pole.
So then would it be the hypotenuse?
Yes, because that's the cable attached. So it's 30 feet, you said?
Mhm.
30 feet pole. Keep going. What more do we have?
22 feet up from the base. So would that be the short leg?
22 feet up from the base. Yeah, that makes sense. Up from the base. Yeah, 22 feet. Uh-huh.
And then yeah, that's all that's given. So
What are we looking for?
You're looking for what is the measure of the angle to the nearest tenth that the cable makes with the ground?
Which angle is that one?
The with the ground. Oh, so it's bottom right.
Correct. So we need this one. Let's call it theta or x or whatever. What do you want to call it?
X. Yes.
Okay. So we got to find x. Which brings us back to the previous types of questions we were answering earlier. So SOHCAHTOA, which of these three do we go with given this and that?
um would be sine, right?
Yeah, because opposite and
Hypotenuse.
so sine x equals what?
Sine x equals 22/30.
Cool beans. How do we find the angle?
You have the x by itself, or no? Yeah.
Sure, yeah, but remember when we're looking for an angle measure, what do we go to on the calculator? If you're looking for an angle measure,
Sine, usually sine.
to the -1.
Oh yeah, sine. Okay, yeah, sine -1. I'm looking for an angle measure.
Yes.
Okay.
Sine or cosine, which if you're looking for an angle measure, that's when you use the -1, basically, is what I'm trying to convey. All right. Tell me what your answer is.
Got 47.166, so 47 degrees.
Yep, x is 47 degrees. Very good. Angle x. Oh, the angle x. The angle the cable makes with the ground is 47 degrees. Very good. So because these are word problems, you are supposed to answer them in context. So I wouldn't just box this really. I'm just being a little lazy, to be honest. What you should have done is said the angle, it should be like a phrase. The angle the cable makes to the ground is 47 degrees.
Okay.
I don't know how nitpicky your teacher is. They
Yeah,
may-
I don't think she won't.
Okay, good.
She wouldn't count on for that.
All right.
Now this is the last part.
Okay.
In triangle ABC, angle C is the right angle. Use the given measurements to find the missing side lengths and missing angle measures of triangle ABC. Round to the nearest tenth if necessary.
Okay, so you're given some angle measurements. You have a triangle ABC. Is it right?
Yep, right.
Yeah,
Triangle.
well, let's sketch a right triangle. It's nice to have sketches, really. Let's sketch it like so. Right angle, A, B, and C. You're given angle B as 50, am I right?
Mhm.
What else is given?
There's a capital B that equals 50 degrees, and then I guess that's a base 18.
So the way this works is capital B is, use capital letters for the vertices, right?
Yep.
Lower cases are the sides up opposite. So this is uppercase B, this is lowercase b. The side here is lowercase b.
Oh, okay.
The side here is lowercase a. The side here is lowercase c. Does that make sense to you?
Yep.
So 18 goes right here. And then we need to find everything else. It's what wait, are they asking us to solve for something in particular or just?
Use the given measurements to find the missing side lengths and missing measures of triangle.
Yeah.
ABC.
So basically find anything that's missing on this triangle.
Okay.
Starting with this. This probably is the easiest thing to find, this angle here. Since you know 90 and 50, what's this one?
90 and 50. Is it the A2 plus B squared equals C squared?
That's for side length, right?
Oh, yeah.
We're doing an angle here.
Oh, okay, yeah, so. So it would be 40 degrees.
Correct. So the way you would answer this, you would say the first thing we did is angle A is 40 degrees.
Okay.
Nice. So I'm going to write 40 right in here. Now we can start looking for this missing sides. Do you want to find A first or do you want to find C first? Really up to you. It doesn't matter to me.
Just B, I guess.
Nothing is missing for B.
So, yeah, C.
So we're going to find the hypotenuse first?
Yeah.
Okay. So now we're going to use SOHCAHTOA
Uh-huh.
to find C. We have this.
Yeah.
Well, first of all, decide which angle are you going to focus on? The 40-degree angle or the 50-degree angle?
Would you focus on the 40-degree one? Or no?
Either one. It doesn't matter.
Oh,
But I'll tell you this. Usually, I avoid using something that I found myself, because if it's wrong and I use it in the next question,
yeah, then it's gonna be wrong.
yes,
So use the 50.
I would rather we do that because it's original. We can't go wrong with that.
Mhm.
So now we have this 50, this angle in relation to this. That's what?
It's opposite.
And we're looking for
the hypotenuse.
So SOHCAHTOA, which of those three do we go with?
Sine.
So sine 50 equals 18 over C. You got to solve for C using algebra.
50 equals 18. C.
C would be,
How would
is
we?
C just 90 degrees?
No, we have to use algebra to solve for this. Like we got to get C by itself.
Oh, okay. So yeah, multiply each side by 18.
That's not going to get rid of. Yeah, so the thing we're solving for should never be on the bottom, right? So that's a big problem currently.
Okay, so we have to get to the top equation.
Yes, we have to multiply both sides by what?
C.
Yeah.
Yes,
Times
okay.
C times C. So of course the C's will cancel on this left side, right?
Yep.
We have C sine 50 equals 18. Does that make sense so far?
Mhm.
So we're closer to getting C by itself. What do we need to do for so C is by itself? What do we need to, we got to get rid of what?
The sine, the 50?
Yeah,
Or
The
sine
sine 50. How do we do that?
You,
What's currently happening between the C and the sine 50 in between
they're
these?
being multiplied.
So how would you,
Divide it.
it, what is it?
Divide the sine 50.
Divide both sides by sine 50. So yeah, those cancel. And then you let the calculator do this for you.
So C equals 18 divided by sine 50.
And then
Let me know what you get.
So would you do 18 divided by, which would be 23.497. So
Yep.
23.
Just say round to the nearest, what?
10.
10th?
Yeah.
23.5 then.
Hmm?
23.5.
Oh, yeah. Okay.
So we now know C is 23.5.
Mhm.
This piece is 23.5. So you have options. To find A, let's go back to SOHCAHTOA. Set it up. How would you find the missing A value?
Do the do the opposites, or would it just be the it would be, let's see, cosine, or no, tangent, right? Would it be sine again? Because those aren't really.
So first of all, we want to go back to the original numbers, 18 and 50, right?
Yeah.
And then we need this one.
Uh-huh.
So
Oh,
what's that really? So this is opposite, and what is this in relation to that?
adjacent.
So SOHCAHTOA, which one has
Oh,
opposite and adjacent? Right, that's how you make the decision. Are you following? So it'd be tangent 50 equals what?
So, and 50 equals, would it be? Oh, it would be, let's see, 18 over 50.
Adjacent from 50 is 50. Opposite,
Oh, that'd just be A.
that's what you're looking
Yeah.
for, right? So then let's do some math over here. You need to get A by itself.
So,
So what do you do?
multiply A.
Yep. Times A times A.
Get the,
It's easy. Okay.
so it'd be A tangent 50 equals 18,
Correct.
then divide the 10 tangent 50.
Very good. Way to go.
And then that leaves you with A equals 18 over tangent 50.
Yep.
Do 18 divided by tangent 50.
Mhm.
Be 15.1.
Good. So you've solved everything that was missing
Mhm.
on the triangle. So to write out your answers, you want to say A equals 15.1, lowercase a, I mean.
Yeah.
Angle A is 40. And then side B is 23.5.
Mhm.
You pretty much keep coming back to SOHCAHTOA with these triangles.
Yeah.
You only use the ones on the bottom if you're told to find the 6 trig functions.
Yeah.
Yeah.
And I just got one more.
Okay.
A equals 14 and then C equals 22. So
Pretty much the same question as this.
yeah.
Oh, by the way, I know I said that we shouldn't use something that we found ourselves, but when I'm 100% sure that it's right, as I am now, we could have used the 40.
Hmm.
We could have used the 40 because we are 100% sure. I only don't use it when I'm not sure. But anywho, I think you get the point. You ready to sketch it? Okay.
So
Wait, you're given, so you got to label it before you go anywhere, right? So A, B, C. And you guess what? You want to make your 90-degree angle C almost 100% of the time. Yeah, so this is lowercase c, lowercase a, lowercase b.
and then A is given.
Which a? Like the angle A or
No,
the?
lowercase a.
Got
And
it.
then lowercase c. So the hypotenuse would be 22.
So 14 and 22, got it.
And then
Find everything else?
Mhm.
Or is it, wait, that's all we're given?
yeah, it's all you're doing.
All right, so where would you like to start? What's the easiest thing to find here in your opinion? Yeah, how would we do that?
You do hypotenuse over adjacent. Is that what it is?
No, this is a side. It's simpler than that. It's as easy as ABC, that's a hint.
So it would be you'd use cosine.
If you have a right triangle,
Oh, so then you'd use just sine, right?
Pythagorean theorem, a squared plus b squared equals c squared.
Uh,
If you have a right triangle and you know 2 sides, finding the third one is just a matter of using the Pythagorean theorem. So you would say a squared plus b squared equals c squared. So 14 squared plus b squared equals 22 squared.
so
196 plus b squared equals 484. Check me. What's 22 to the second power? I don't know.
22 to the second power. 44.
Okay. And then what do we do next? Wait, you say 484?
yeah.
Okay, cool. And then what do you do next?
You just subtract the 196.
Yep.
So on that side, so
Mhm.
Minus 196. 9288
Yep. And then square root of 288.
is 288.
Well, we don't want a decimal. We want to leave it in this format. How did I get that? You're probably wondering what. So square root of 288. it's not a perfect square,
Mhm.
but a while back we learned how to simplify these radicals. We're like, we got to find two numbers that multiply together to give us 288. And those numbers are 144 times 2. What's the square root of 144?
Square root of 144 is 12.
So that's how I got the 12, because the 12 goes out root 2.
Right.
So we now know this is 12 root 2. It's probably time for you to go back to class, by the way.
Yeah.
So once you have the three sides, you can find all the missing
Yeah.
angles. So I can get you started on the first one. Do you want to do A or B first?
We'll do it.
So angle A, this one,
Mhm.
we have a choice. Do you want to use sine? Do you want to use cosine? Do you want to use tangent?
At least sine, I guess.
So sine of angle A equals opposite over hypotenuse. We're looking for an angle measure. So what do we have to use on the calculator? You're looking for an angle measure.
You have to use the -1.
Correct.
So just say -1 and then the 14, yeah, 14 divided by 23. And this would be 39.5.
Right. So angle A is 39.5 degrees. So 39.5 degrees right here. All right. Since this is a triangle, guess what? Finding the missing one is just subtract the sum of these from 180.
Mhm. So. Wait, but we don't have C or B.
We do have C.
Oh, we do.
It's 90.
Oh, yeah. Is it, wait, C's the 12 square root 2? Or,
C is 12 square root 2 is a side. C is an angle.
oh, yeah, it's 90 up.
Mhm.
So,
39.5.
Mhm.
so it'd be 50.5.
You've solved the whole triangle.
Mhm.
That's it.
Alright.
You're welcome. All right, gentlemen, that's your review. I don't think these guys are doing something entirely different. So you probably are doing catch up still.
Yeah.
All right, so I'm gonna stop the recording. Cool. I'll send this to you.